Welcome to Gumber's mathematics classes. Hope you liked the video. Subscribe our channel and press the bell icon to never miss another updates.
Hello everyone, our today's topic is quadratic equation. Before going to quadratic equations, let's recall few of the terms like polynomials, quadratic polynomials. Then we will come to quadratic equations. Very first is polynomials. Polynomials are the algebraic expression in which the power of the variable is whole number. Let's consider few of the examples. X square plus 5x plus 9, it's a polynomial. X raised to the power 100 plus y raised to the power 25, it's also a polynomial because the power of the variable is a whole number. Now let's consider one or two examples which are not a polynomial. Not a polynomial are under the root x plus y. This is not a polynomial as x power is 1 by 2, which is a fractional number. 1 upon under the root of x, this is also not a polynomial. Next is 1 upon y, this is also not a polynomial. Now quadratic polynomial. Quadratic polynomials are the polynomials in which the highest power of the variable is 2. As we consider, this is a quadratic polynomial. Let's consider few more quadratic polynomials. X square minus 1, x square plus 5x plus 9, or x square or y square. These are the examples of quadratic polynomials. Now the general form of a quadratic polynomial is of the form ax square plus bx plus c, where a, b, c are real numbers. Any of the real numbers, these belongs to the set of real numbers, and a, the coefficient of x square should not equal to 0. What will happen if coefficient of x square is equal to 0? Then it will become a linear polynomial, because this if a is equal to 0 will be getting bx plus c, and this is only x raised to the power 1. Therefore it would be a linear polynomial. But we want to talk about quadratic polynomial. It means a should not equal to 0. Of the form ax square, b can be 0, no problem, c can be 0, no problem, but a should not equal to 0 in the case of quadratic polynomials and equations. Now the next point is quadratic equation. What are quadratic equations? When we equate quadratic polynomial with 0, we get an quadratic equation. Let's consider an example. Let us consider 2x square plus 5x plus 9 is equal to 0. This is the example of quadratic equation. The next is, if we consider x square minus 1 is equal to 0, this is also a quadratic equation. Now the general form of a quadratic equation, let's remove this. General form of a quadratic equation is ax square plus bx plus c is equal to 0, where a, b, c belongs to real numbers, belongs to real set of real numbers, all are real numbers, and a is not equal to 0. Similarly, as in case of quadratic polynomials, a should not equal to 0. Now the next point is why to use quadratic polynomials, when to use quadratic polynomials. Now let us consider one example. I have a plot of area 300 squares. I can purchase, right now I am not purchased, let us consider I want to purchase 300 meter square area to prepare my new home, and I am considering that its length should be 1 more than the twice of its width. What I consider, its length should be 1 more than the twice of its width. It means I should consider width to be x and its length is to be 1 more than twice its width. So this is these are the dimensions, and total area I want to be 300 units square. So it means what we need to do, it means area means length into breadth. 2x plus 1 into x, it is to be equal to 300. Now let's see, open this bracket, we will be getting 2x square plus x is equal to 300. This is 2x square plus x minus 300 is equal to 0. Now this is a quadratic equation, and find the dimensions, that what should be the breadth, what should be the length, I must know the value of x. And the way how we can solve these, because the solution of this quadratic equation will only give me the values of the dimensions of my plot. So this is the reason why we want in real day-to-day life we want these. Next is the standard form. This already we have done. The standard form of a quadratic polynomial is ax square plus bx plus c, where a, b, c belongs to real number and a is not equal to 0. And if we equate it with 0, we will be getting a quadratic polynomial. Now few of the examples of quadratic polynomial, as here the highest power of the variable is 2. Therefore, yes, it is a quadratic polynomial. 4x minus 3x square plus 2 is equal to 0. Here also highest power of the variable is 2. Therefore, it is also a quadratic polynomial. Now 1 minus x square plus 300. Here also the highest power of x is 2. Therefore, this is also a quadratic polynomial. Let's have some examples related to which are not quadratic polynomials. Here are the few examples which are not the quadratic polynomials. 2x square minus 3x cube. Let's remove this, extra ink notations are there. 2x square minus 3x cube plus 1. Here the highest power of the variable is 3. Therefore, it is not a quadratic polynomial. Here in this particular case, this is a cubic polynomial but not a quadratic polynomial. Now here 4x plus 2. Here the highest power is x raised to the power, highest power is 1. Therefore, also this is not a quadratic polynomial, this is a linear polynomial. Next is x under the root minus x square 300. Yes, it seems to be highest power is 2, but we have to be very alert. This is under the root x. Under the root x, it means it is not a polynomial. Without equating, it's not a polynomial. If it is not a polynomial, it cannot be a quadratic polynomial. If it is not a quadratic polynomial, we cannot get a quadratic equation. Hence, these are the examples which are not quadratic equations. Bye bye.